So now that you've done your own scientific experiment, we're going to return back to the ideas we discussed in the introduction and kind of explore in depth how science works, what are the key elements of science. We're going to be returning back to the scientific method, organized skepticism, and one of the ideas that is absolutely critical in science that tends to not be, it happens in other areas, but it doesn't get emphasized as much. And this is the idea of what we were going to call operational definitions. In science, you have to be so careful and precise with your definitions because you're planning to do a precise and careful experiment. And you may not like the definition, but you have to accept it as a community and all agree on the precise nature of the definition. And a great way to illustrate that is to think about solids and liquids, because we're all very familiar with water freezing and turning into ice. Okay? And so I could ask you, what's a solid? What's a liquid? So take a few minutes or a few seconds and think about what would be your definition of a solid and what would be your definition of a fluid. Now, I ask this question a lot, and there's basically two categories of answers. There's what I call the grade school answer, and this is actually not to put it down. It's actually a very good answer. The grade school answer is what my daughter just learned in 4th, 5th, and 6th grade. A solid holds its shape, and a fluid takes the shape of its container. Okay? Now, the slightly more advanced, and I say advanced in quotes definition, asks about the molecules. In a solid, the molecules have fixed positions relative to each other. They're bound tightly. In a fluid or a liquid, the molecules are free to move around each other. Okay? This raises an interesting question. Is sand a solid or a liquid? Okay? Well, if I just pour sand, it takes the shape of its container. But if I'm a molecule inside a sand grain, I clearly think I'm a solid. Okay? I'm in a rigid situation. All my neighbors are well defined. Okay? To make matters even more confusing, after pouring my sand into a cup like this, okay, which I just showed was fluid, it took the shape of its container, I can tap the sand. I'm rearranging the sand grains. They're changing their neighbors. They're changing how they're attached to each other. Okay? And having done this, I solidify my sand. The sand itself is holding the paper towel tube up. I've turned what was looking like a fluid into a solid. Okay? This is a transformation that's occurred through physics and science. And now we really have to ask questions about our definitions. Which is the right definition to use? Which is the most useful operational definition? Is it the molecular one, which never could have predicted this behavior? The molecular definition never changed. Every molecule stayed the same. Or is it my grade school definition? Turns out to be much better, whether it's holding its shape or taking the shape of the container. As I poured it, it took the shape of the container. Once I tapped it, it held its shape and became rigid. So rigid that it acts like cement with this paper towel tube. So in this week's lesson, pay close attention to how definitions are used and how important they are to the way we do science.